And if it's the odd multiple of the pi, cosine of the 2k plus 1 times pi, then we know this is equal to -1, right? And then this implies secant of the 2k plus 1 times pi is also equal to -1. Okay, 1 over the -1, right? Equal to what? Equal to -1. And since secant function is the reciprocal of the cosine function, then we know when cosine function increases, secant decreases. And when the cosine decreases, secant increases. So we may first draw the graph of the cosine function, and then based on this graph, we can draw the graph of the secant function. So let's begin with the graph of the cosine function. Okay. We know the graph of the cosine is like this. Right? So now, at the point where the cosine is equal to 0, the secant function has the vertical asymptotes. So at here, cosine is equal to 0. Then we have the vertical asymptotes for the secant function. And also here. Right? And here. Okay? And then, when cosine is equal to 1, secant is also equal to 1, right? So that means the graph of the secant function goes through this point. And when the cosine is equal to the -1, secant is also equal to -1. So the graph of the secant function goes through this point. And when cosine x decreases, the secant increases. And when the cosine x bigger than 0 and approach the 0, this secant function just approach the positive infinity. So you can get the graph of the secant function in this part like this. Okay. And when the cosine decreases, actually this part cosine is increases, and then secant function is decreasing, right? So you can have the graph of the secant function like this. And similarly, you can find the graph of the secant function in this interval. Okay. So for other part, you can also find the graph of the secant function. Okay. So we base on the graph of the cosine function, and then we get the graph of the secant function. And from this graph, you can see the range of the secant function is either this secant function is bigger than or greater than 1, greater than or equal to 1, right? Or this secant function is less than or equal to the -1. Actually, from this identity, we know secant of x, its absolute value, is equal to 1 over the absolute value of the cosine x. And we know the cosine, okay, the absolute value of the cosine x is less than or equal to 1, right? Always between the -1 and the +1. So now, from this inequality, you divide both sides by the absolute value of the cosine x, then you get 1 less than or equal to 1 over the absolute value of the cosine x, right? So that means this guy is always greater than or equal to 1. So from here, you know the range of the secant function must be the union of these two intervals. So that is either from the negative infinity to -1, right? Union interval from positive 1 to positive infinity. Actually, this is a solution of this inequality involving the absolute values, right? So this is the range, okay, the range of the second function. Now let's look at one example about the second function, and let's try to graph this second function for one cycle and determine the period and the range. So our example is like this. Function y equal to 3 times secant of 2x minus the half pi. Okay. So first, let's determine its period and the range. So as in the cosine function, the period of this second function is equal to 2 pi divided by the coefficient of x. So that is 2 pi over 2. So that is pi. And the range, so the absolute value of y, which is equal to the absolute value of 3 times secant of 2x minus the half pi. So this is equal to 3 times 1 over the absolute value of the cosine of the 2x minus half pi, right? And we know the absolute value of the cosine is less than or equal to 1, so this reciprocal is greater than or equal to 1. So this is greater than or equal to 3. So the range for this given function is equal to the union of these two intervals from the negative infinity to negative 3, union the interval from the 3 to positive infinity. Now, we need to draw one cycle of the graph of this function. So we know the fundamental cycle of the second function and the cosine function is from the 0 to 2 pi, right? So to determine the one cycle of this given function, we just let this, okay, expression inside the parenthesis between the 0 and the 2 pi. So we let the 0 less than or equal to 2x minus half pi less than or equal to 2 pi. Then we solve this inequality. We can find the fundamental cycle of this function. So we add the half pi to each part. Then we get the half pi less than or equal to 2x and less than or equal to half pi plus 2 pi, which is equal to 5 pi over 2, right? Half pi plus 2 pi equal to 5 pi over 2. Now we divide each part by 2. Then we get pi over 4 less than or equal to x, which is less than or equal to 5 pi over 4. Okay?